In this series, we are going to explore a special part of mathematics which is called cyclic geometry. And then let's try to first locate, or rather identify, that where can we place this cyclic geometry in the mathematics syllabus. Where does it fit in? First things first, mathematics as a subject is just the study of number, shapes, patterns, and how they relate to each other. That's the mathematics. And then under mathematics, we've got different branches. We've got algebra, we've got geometry, and whole lot. But now it's under geometry. What is this geometry? This is the branch of mathematics that deals with shapes, sizes, position, and properties of figures. Now, under the geometry, there is a geometry that is specializing with shapes. There is a geometry that specializes with lines and figures. And then now we are going to narrow it down to focus on the one that deals with shapes, which is the Euclidean geometry. This is the system of geometry based on points, lines, angles, studied by the Greek mathematician, which is Euclid. And then under this Euclid geometry, we are going to look at the cyclic geometry, which is the part of the Euclidean geometry that studies cycles and their properties, angles, chords, tangent, arcs, and related theorems. So basically, our cyclic geometry lies under mathematics, and then it's under geometry. Under geometry, we are looking at Euclidean geometry, and then under Euclidean geometry, we are further breaking it down to cyclic geometry. Now, maybe before we go even deeper, let's try to define what a cyclic is. So a cyclic, it's a collection of points that are equidistant from a fixed point. For example, we have this point here, which is 5, 0. It is 5 units from the origin. Another point that can be 5 units from the origin, it's this point here, which is -5, 0. They are both 5 units from the origin. Another point is there, another point is there, and there are a whole lot of these points, even between these two, even between these two, even between those, and even between those. So the collection of all those points that are 5 units from the origin are going to give us a shape, which we call it a cyclic. So basically, that's what a cyclic is. It's a collection of points that are equidistant from the origin. Now, a cyclic, the fixed point in the cyclic, the fixed point in our case is point E. It's called a center. Now this is the center. That's the center there. And then this is the center of a cyclic. It's the fixed point that is equally distant from every point on the cyclic. So that is your center. Next, let's define a radius. Now, if you can draw a line from the fixed point, or rather from the center, if you can draw a line from the fixed point or from the center to any point on the circumference. All those lines are going to have the same distance, no matter where you go on the circumference. No matter where you go, that is what we call the radius. It's the point, it's a line drawn from the center to any point on the circumference of the circle. Next, we are going to define a diameter. What is a diameter? If you draw a line from a point, if you draw a line from a point on the circumference to another point on the circumference, and this line is passing through the center, it's going to be double the diameter. It's going to be double the radius, and then as you can see, it's 10 units, and it's double the radius. It's called a diameter. So to define a diameter, we say a diameter is a straight line that passes through the center. Very important. It must pass through the center and has both end points on the circumference. With a formula, the diameter V is equals to 2 times the radius. Now, what is a circumference? Circumference is the boundary of the perimeter of a circle. The boundary or the perimeter of a circle is called the distance around a circle, the part that covers a circle, the line that joins all the set of points that are equidistant from the center is called the circumference or the perimeter of the circle. Next, let's define a chord. A chord is a straight line connecting any 2 points on the circumference. We've already drawn a line that connects the 2 points on the circumference. For example, our line AB here, it's called a chord, but it's the longest chord in this circle. Check its distance here. How if I decide to move it? Unfortunately, I can't. Let me try this. Nice one. I want to make sure it passes through the center first so that I can also show its distance. It's 10 units. That's the diameter. It passes through the center and its endpoints are on the circumference. Now let's try to move this. It's going down, and then this one is now called a chord, and then the diameter, it's the longest chord in the circle, because check this, if I bring it, if once it passes through the center, it's 10 units. Anywhere else it's below 10. It's just a chord. Its definition is a line connecting any 2 points on the circumference. Now let's check what is an arc. So an arc is a part of the circumference between 2 points. So a part of the circumference between 2 points, we call that an arc. Let's try to draw an arc here. Now this is an arc. It's a part of a circumference. So if I go around, it becomes a circle. But if I draw a smaller one, it becomes an arc. So that's a part of the circumference. The bigger one, this one is called the major, and then the smaller one is called the minor. So that's just an arc, a part of the circumference. And then let's move on to these definitions. Now we are going to a sector. What is a sector? It's a region of a circle enclosed by two radii and the arc between them. Now let's say you have a circle here. Please don't judge me, that's not a perfect circle. And then from there, you draw a radius, a line from the circumference to the center. And then from there, this region here, the whole of this is called a sector because it is enclosed by a radius together with an arc. That is a sector. And then let's check this one, the next definition. As a sector, a segment is a region cut off. A segment is a region cut off by a chord and the arc between the chord's end point. A region cut off by a chord. Did we define what a chord is? Yes. So let's try to draw this one too. We have a circle there. And then this is our chord. And then we have an arc here, this side. This is an arc. And then that's the smaller arc, which is called the minor arc. Then the other arc, this one, this side, is called the major arc. Now, what is a segment? We are saying it is the region cut off by a chord and the arc between the chord's endpoint. So this is our sector here. This region, sorry, the segment, that's the region there. Now a tangent is a straight line that touches the circle at one point only. I think we should go to GeoGebra for this one to try to illustrate. Let's try to draw a circle This is our circle. And then let's draw this line. The line I've drawn is called a secant line. And then the secant, it's a straight line that cuts exactly at 2 points. It passes through the circle at 2 points. That's a secant line. And then if I play around with the secant line, try to move point C to point B. Or rather move point B to point C. Let's try this. Let's move this one. It's called a secant line if it cuts at 2 points. Let's move it, move it, move it, move it. Still 2 points, still 2 points, still 2 points, still 2 points. Then now it's exactly at 1 point. Now this line, this secant line, it's a secant if it, but then now it's touching at exactly 1 point on the circle. So this line that is touching exactly at exactly 1 point. It's now touching from here. It's a secant. Then if you move it, it touches at exactly 1 point. We no longer call it a secant line, but rather we call it a tangent. We are going to explore the theories around tangents and circles. For now, we're just providing the definition. So it's just a line that touches a circle at exactly 1 point. Next definition, a semicircle. What is a semicircle? Semi means half. Circle, you already know what a circle is. So a half of a circle, it's a semicircle. Half of a circle formed by cutting the circle along its diameter. We are going to get 2 equal halves. Then 1 half is called a semicircle. If you join 2 semis, you are going to get a complete circle. And then the next definition I'm seeing here is quadrant. Quadrant from quarter. So this is 1/4 of a circle, a section that is 90 degrees. Let's try to draw this one. Let's say this is our circle. That's our circle there. Let's try to divide this circle into 4 equal parts. Like that. And then this is now called a quadrant. Was it's the first quarter, the second quarter, the third quarter, and then the fourth quarter there. So that's what a quadrant is. So basically, those are the basic terms linked with circles. Now, let's try to lay down or rather define some of the formulas linked with circles. The first one, we are going to define a diameter with respect to a radius. We have a diameter d, which we say this is equals to 2 times the radius. Another one, we have the circumference c. circumference, it's 2 pi r. If you like, 2 times r. 2 and r gives you this one, which is the diameter. So this formula can be redefined to pi times d. So that's how you calculate the circumference of a circle. And then when it comes to area of a circle, it's nothing but pi times the radius squared. In terms of d, it's pi times the diameter over 2, all squared. And then another one, it's the sector. To calculate the sector, the area of a sector, area of a sector, it's going to be a part of the whole area of a circle. So to define the part, it's going to be the theta. It's called, let me call it the x, which is the angle of the sector, divide by 360, then multiply this fraction by the area of a circle, which is pi times r squared. And then for the arc length, still arc length is a part of the circumference. So to define the part, we are using the angle divide by 360 and then multiply this fraction by the formula for calculating the perimeter of a circle, or rather the circumference, which is 2 pi r. And basically those are the few formulas around circles. Stay tuned for more. In our next lesson, we are going to explore a theorem called, which says the angle at the center is twice the angle on the circumference of a circle, which is going to be our first theorem on circle geometry. Angle at the center twice the angle on the circumference. We first start by proving that theorem and then define it and then apply it in practical examples. Thank you. Stay tuned for more.